So first one, you use a calculator to check that determinant of this metric A. We obtain the value which is 52, so which is not equal to 0. And then second rule, you have to prove AII, okay, greater than 0. Means you have to prove A11, A22, A33, A44. Okay, since all these four values are greater than 0, so it's satisfied. And then number 3, okay, number 3 you have to show what? Okay, number 3 you have to show, I think, maximum of your magnitude AKJ less than or equal to the maximum of the AII. Okay, mean maximum AII is actually from 4 diagonal value. Pick up the maximum, which is 9. Okay, and then AKJ is actually non-K diagonal value. Okay, which one is the maximum? If you have negative, take the magnitude, so become positive. Okay, so from the non-diagonal, you have 2, 0, 0, 1, 0, 4. Okay, you can either focus on the upper triangle, upper part or lower part because they are actually symmetrics. Why the name symmetrics? So they must be symmetric respect to diagonal. Mean A12 equal to A21. Okay, and so on. And positive, so means main diagonal must be positive value. There are 2 quick check for the symmetric positive definite. Okay, and then the third rule is actually identify the maximum of the magnitude of the non-diagonal, which is 4. Okay, 4 which is less than 9, so it's satisfied number 3. And then number 4 you have to check AIJ squared less than AII AJJ. Okay, so mean you have A12, since they are symmetric, A12 squared equal to A21 squared, okay, which is 2 squared equal to 4. Okay, you check, is it true? Less than A, you have A12, so it's A11 times A22. Okay, A11 times A22, you have, 1 multiply 9 equal to 9. Okay, 4 is less than 9, so it is true. Okay, check against the A13 squared. Okay, is it equal to A13? So A31, okay, which is 0 squared equal to 0. Is it equal to? Is it less than A11, A33? Okay, so A11, A33 is also equal to 1 times 9, which is equal to 9. So it's true that 0 less than 9. So this one also satisfied. So you have checked this. Okay. Since A14, okay, A14 squared equal to A41 squared. A14 here. This is A12, A13. Okay, A14 squared is equal to 0 squared equal to 0. So is it less than A11 times A44? Okay, which is 1 times 3. It is true 0 less than 3. So it's satisfied. So you have checking this one, A12, A13, A14. Now you go to check this one. Then you want to check all this value. 1, 2, 3. So checking another one, I think A23. Yeah? Right. A23 squared is equal to A32 squared, which is 1 squared equal to 1. Is it less than A33 times A22? Okay, A33 times A2, okay. So A33, A22, okay. 9 times 9. 81. So 1, it is true less than 81. So satisfied. So 2 more, you have to check A24 squared is equal to A42 squared, which is 0 squared equal to 0, and then check is it less than A22 times A44. Okay, A22 is 9, A44 is 3, so 9 times 3, 27, so it's true that 0 less than 27. Okay, so it's just left A34. A34 equal to A43 because they are symmetrics. A34, you have 4 squared is 16. Okay, so you have to check is it true less than A33 times A44. A33 is 9, A44 is 3, which is 27. It is true that 16 less than 27. So this is the first part, show it is symmetric positive definite. Okay, after you show it is symmetric positive definite, okay, you have to use, you want to do first step. Okay, because it satisfied this for rule, so this one is symmetric positive definite.
Let's say if it's not satisfied the rule, we have to use another method.
No, if one of it not satisfied, so this is not symmetric positive definite, then you cannot use Cholesky. Only symmetric positive definite, okay, matrix, then you can use Cholesky method. If this is not symmetric positive definite, then you can either use Gauss elimination, okay, and this one, okay, this matrix is actually also 3 diagonal, so you can also use Thomas method. As you see, we have only three diagonal there. You can also use Thomas method, or you can use Gauss elimination method. Or you want to use Gauss elimination with pivoting, then you have to swap second row become first row to make sure magnitude A11 is the maximum before you reduce all the entry below A11 is 0. And then later on, when you want to eliminate all the entry below A22 becomes 0, make sure the magnitude of A22 is a maximum. Okay, later on, when you want to eliminate the entry below A33 is A33 becomes 0, make sure magnitude A33 is maximum. There is Gauss elimination with pivoting. If Gauss no restrictions, no need to swap row. Okay, you just make this entry 0. And then later on, this one 0, 1, 2, 3. I think 3 step only because this is 3 diagonal. So for Gauss, you just make this one 0. Make this entry 0 using suitable row operation. This suitable row operation, 3 step only in Gauss. Okay, and since this is symmetric positive definite, if you want to use you want to use the Cholesky, you have to the same technique. You extend from 3 by 3. Okay, A here chain to the equations. Okay, exercise 4, exercise 3, equation 4a. A here you chain. Okay, this is your L. This is a U, which is L transpose. Okay, Cholesky U is L transpose, and L. Okay, the name of L is lower triangular matrix. So denotes your lower triangular matrix using any variable that you like. Okay, I will just label it as A, B, C, D, E, F, G, H, I, J. And then the U is L transpose because it's a symmetric matrix. So you transpose it. Okay, first column A, B, D, G become first row. This is transpose. Second column become second row. Third column become third row. Fourth column become fourth row. Okay, and this is a result of your matrix multiplication, 4 by 4 matrix. similar with your 3 by 3. The only difference is the extension, okay, to this is 4 by 4. If you have 5 by 5, the same concept. You can extend it up to n by n. It's only is, okay, to do your metric multiplication and to find the L and U there. Okay. Means you have to carefully multiply L and the L transpose here. Okay, and then you obtain this one. And then you just compare. You have 4 by 4. You prepare. I will suggest that you prepare like here. If you have 4 by 4 system, you prepare 4 by 4 column here. Okay, will be more systematically, okay, compared to you write everywhere. You write everywhere later on. You want to find where is it, because you put it, okay, 4 by 4, and then you just compare according to its position here. Row 1, column 1, a squared equal to 8. And then for Cholesky, okay, even though you know that square root, you have positive, negative, always takes positive only. Because the diagonal value is always positive. You see here, this is actually at the diagonal. The value A, C, F, G, A, C, F, here, A, this is C, this is F, this is J, is actually at diagonal. A, C, F, J. Why we take positive? Because the diagonal of Cholesky must be positive. Must be positive. That's why, okay, when you take square root, only take the positive square root. So the technique are the same, just you have to extend it. So, okay, Dayang. So what is the problems there?
Oh, I think I forgot to transform the
This one,
one
U
to turn it into 0. Right, we have to do that so that the second, third, and fourth will be 0, because it's only the last for the first row, the last column, and the second last column 0. You need to change it like the second row, the first row, second column must be 0 too, right?
No, that is Thomas.
Oh, but this one, I sent you in the Telegram.
Okay, if you make sure, okay, if you put up this one, mean you solve it using Thomas, because that system also Thomas. If you put this 3 and 3 0 in the L, and then if Thomas, okay, in the U, diagonal of U is 1, and then these 4 and 3 are 0. Because that question also, okay, this one also you can solve it using Thomas. But if you put, okay, all that part 0, mean you're using Thomas method. Okay, you see Thomas method, mean if you want to use Cholesky, this is a product of your L and L transpose, and then you equal back to this this one. Copy it. Mean you, okay, if you use Cholesky, then you will compare actually this cell, okay, A squared equal to 1, your A is 1, AB equal to 2, okay, then since A is 1, then your B is 2, AD equal to 0, hence your D is equal to 0, AG equal to 0, since A not 0, and then your G is 0, and so on. If you use Cholesky, okay, I wouldn't care this, okay, this entry as 0. Cholesky is actually A equal to LU, where the U is L transpose. Okay, the L here, DGH here not equal to 0. Because if you make it 0, then you use Thomas. If you use Thomas, diagonal of the U here is 1. Look at the Thomas. This is Thomas. That question also you can solve it using Thomas. So if Thomas, you see this one, A, B, C. This entry must be 0 to satisfy when you multiply it. The lower part means A31, A41, A42 is 0. And then if you use Thomas, diagonal of U must be 1. And then upper part here, A13, A14, A24 must be 0. So that when you multiply, you will get back 3 diagonal.
So I already tried to solve it. But the first one, the equation for the first, the A11 is A squared plus BE. So there's 3 unknown there. But for this one, it's only 1, only A for the unknown. I sent you in the Telegram.
I'm in class. I cannot open too many things. Okay, on. You must have somewhere mistake. You want to use Thomas. Let's check your. You checking your L, the product LU, whether correct. Is your metric multiplication is wrong. A squared only. I saw, your answer, your metric multiplication is wrong. Put this one to here. You see, it's your metric A, B. Your L also wrong. Dayang. Your L is wrong. L is lower triangular matrix. Start from diagonal because your L is wrong. Like this. First, you must understand what is lower triangular matrix. Start from diagonal. Only upper part consists of value. Because first, your L is wrong. A, B at here.
I see.
And then, that's why you in your L there, you don't have the E here. You see, I got 1, 2, 3, 4, 5, 6, 6, 0 here.
Yeah, I see.
And then U, for Cholesky, this is a L transpose. I thought you solve it using Thomas, but your entry is wrong. The start from L is wrong. U is actually from the diagonal. Only upper part consists of non-zero value. That's why that's why if you form the L and U wrongly, then wasting time for you to do your metric multiplication. This is wrong. So then the rest will be gone. So it's very important to get the correct L and U. So Cholesky, U is L transpose. If Thomas, the DGH here is 0. And then, and the U, diagonal of U is 1. And then, also, if you look at Thomas one, because it's very important you get the correct one. When you get the wrong L and U, wasting time only. This is a Thomas K for 4 by 4. The keyword K Thomas, U at the diagonal must be 1. And then this part 0, bottom part 0, so that when you multiply these two matrices, you will get back 3 diagonal matrices. So Dayang.
Really understand.
This one. Because L and U wrong. So this is a product. Later on you compare element by element only. And you should be able to obtain A until J value here. Just the square root take positive because diagonal here is always positive value. Because the A, C, F, J is always positive. Okay, then we go back. Okay, just now who?
Thank you, Doctor.
Okay, Ahmad Mubasir. Ahmad Mubasir, Ahmad. Left already. Okay, Ahmad, are you here? Calling, no response. So what to do? Let's see whether he's still here. Got lah. Ahmad Mubasir, can you respond? Okay, what is the progress? Person there that but don't want to respond. Call next one first. Aini. Yes.
Doctor.
Have you completed?
I already complete, but I don't get the exactly answer. But I already tried.
Then you just question 3.
Yes.
Okay, you just I stop and let you present.
Alright.
Okay, those who don't want no response, don't not say that you don't respond, then you skip. We still want you to either you post to your into the Telegram there. Okay.
Doctor, can you see my start?
Hold on.
Alright.
Yes. Hold on. Can bigger. Like just now. You zoom it, make it bigger. Okay. And W squared. Why you want the W squared there? Bigger a bit. Okay. You make it W squared. Okay, first of all, your substitute is correct. X is 0.5. G 9.81, and then T is 1. Okay, you make it like this. Oh, I know the problem. Maybe you cannot differentiate, is it?
Yes.
Okay, I know why this question, the the question asks you to use a Newton, okay, using the secant. Okay, it's correct. You put it that way, and then you swap omega squared up, and then where's the 4 there? I need, okay, you move your omega squared to the left side, you move 0.5 down. Okay, how about 4? Divide by 4. Where's the divide by 4 there missing?
Oh yeah. I think I missed. Yeah lah, doctor.
I need.
Yes, doctor. I think I'm doing wrong with this solution.
I need. Are you here?
Yes, doctor. I think
I need.
Yeah.
I can't hear you.
Oh my gosh.
Your equation is wrong because you left out that divide by 4.
Yes. Oh,
I
yes.
couldn't hear you.
Oh my god. I can hear right
Okay,
now.
can the rest of you hear or not? Okay, what she is talking? I need. We cannot hear you.
Hello, doctor. Can you hear me?
I need. We cannot hear you.
Hello, doctor.
And it's actually wrong because you missed out that divide by 4 term.
Yes, doctor. I think I mistake.
Where you are? I cannot hear. Hold on. I accidentally off. No. Oh yeah, I can hear. Accidentally off it. Okay, I need.
Yes, doctor.
Okay, your equation is wrong already because you left out the divide by 4.
Yes, I see that.
And actually, you no need to put it this way. You just bring 0.5 to the rest, become minus 0.5. But maybe you face difficulty to differentiate this one.
Yes. I don't know this question.
You may face difficulty to differentiate. Okay, never mind. You stop. You can stop present first. But okay, your equation that you form here is wrong because you left out divide by 4. Okay, the exercise 2, question 3. The xt equal to negative g divide 4 omega squared exponent of w or omega sin wt. You plug in w the x
Doctor,
is
are you hearing
0.5.
me?
You want to find the value of w in the equation by taking the interval -2 to -1 using secant. Why the question said secant? Because using Newton may have difficulty to differentiate. Okay, t is 1, so exponent omega plus cos.
So you are now sharing your screen.
This is sin omega because t is 1. And then you make it become a nonlinear function. If you want to make become nonlinear function, f is a variable of w. So I will just straight away put it as, okay, collect to the same side, 0.5 plus 9.81 divide 4 omega squared w, exponent w plus sin w. Or you bring 0.5 to the other side, will become so negative. So now this one become function. Mean you collect to the same, okay, here, same side. So 0.5 plus 9.81 divide 4w squared multiply exponent w plus sin w. To use Newton, if you use bisection will be long, okay? That's why the question asking using secant, which is not too long compared to bisection. But if you use Newton, you have to find f prime w. So mean you ddw the functions here. So you dd, okay, ddw 0.5 you have 0, and then you have to differentiate this one respect to w, and it's a product form. So you have to use the product rule such that first use the product rule. The u is 9.81 divided 4 w squared. Oh, is 9.81 for
Doctor?
w negative 2. The v is exponent w plus sin w. So differentiation you have learned in your first subjects. I'm not sure whether your faculty call it as calculus or last time they call it engineering mathematics 1. So to use Newton method limitation, you must know the how to do the differentiation. Otherwise, you have to ask a calculator to differentiate for you. So the u prime, you differentiate it respect to w. So you have negative 9.81, 2 and 4 simplify, you have 2 here. So w negative 3. This is v. So v prime, differentiate exponent w. So you get exponent w, differentiate sin w, you get positive cos w. So this is your product rule. Mean the result is uv prime plus vu prime. So your f prime w will be 9.81 for w squared multiply exponent w plus cos w. Here, this is u v prime, and then plus v, which is exponent w plus sin w, okay, multiplied with u prime, which is negative 9.81 divide 2 with it omega negative 3 put down become divide w cube. You may collecting back exponent w plus, oh, not same.
Sorry, but you are
Just keep it this form. So this is your f prime w. And then scale for Newton. If you use Newton's method, they give you the interval -2 to -1. You can either pick your starting point is -2 or -1. So you have this is your I. You have what? W. F W. Your F prime W. Okay, I. Let's say you pick -2. Then calculate your F W. F prime W. Okay. Next one. Okay. W1. You calculate using WI plus 1 is equal to W. Okay. I. Minus of minus F WI divide F prime WI. Okay, this is a Newton's method formula. Okay, so you can calculate it, I think, using the calculator, or you can use the Excel to calculate it. So if you use calculator, this is your FW here, 0.5 plus.
Excuse me, right there.
Okay, we don't have W, so change it to X. Okay, this one is a F W. Of course, calculator you don't have W. I change it to variable X. Then you calculate. Okay, I choose a starting point is -2. Then key in -2. Okay, let's say fix to 4 decimal place. Oh. So you get this is 0.0255. Okay, so this is FW. Later on, okay, key in your F prime W into your calculator. Okay, so this is the first term, U V prime, and then okay plus okay V U prime, which is exponent X plus sin plus sin. And then V is here, V U prime, U prime. Okay, before you calculate, double check whether you key in correctly in your calculator. Okay, once correct, then you calculate x is -2 because just now we key in for function fw already. So if you want to accept, just press equal. So answer you have -0.6467. Check it whether the Newton methods formula correct. Okay. So you want to calculate W1. So I start from 0. When you start I equal to 0, you will get W1 equal to W naught minus F W naught divide F prime W naught. Okay, where I denote in your calculator is A minus B divide C. Okay, means this is A, this is B, this is C. Then you obtain W1. Okay, I here to indicate because you have W, F, W, F prime, W, so many rows. So this is W naught, this is F, W naught, F prime, W naught. Now you want to calculate W1. Okay, using the formula A minus B by C. Calculate. Okay, key in A is -2. Okay, B 0.0255. C -0.6467. So you get -1.9606. -1.9606. Search back your fx. Okay, because here you want to search back up 1 time, you get this formula. Up 2 times, you get fx. Okay, this function 1 more time, you get here this function just now, which is 0.0255. Okay, so now calculate. Okay, actually this value is stored in answer. Okay, if you press answer, okay, even though we fix to 4, I think they will take up all decimal place. If you lazy, you press answer, it's actually take this value. If take answer is actually, if you press answer, mean they will take up all decimal place. If you key in, then you key in -1.9606. So the answer will be run a little, a bit compared to if you use up all these things. Okay, let's say if I put this, if you accept this one, you equal. Okay, now I get this is -0.00030.004. Okay. Since if you take this magnitude FW1, since magnitude FW1 magnitude, so it's 0.0004 less than epsilon equal to 0.0005. Okay, therefore, okay, the root is approximately W1, which is equal to -1.9606. Okay, you check the answer. Okay, the answer provided is using secant method. Question 3. Yeah. Okay, run a bit because the answer provided is using secant method. Okay. If this one, I calculate that. If I put, you see, if I put -0.9606, sometimes the answer will run a bit. So the answer in the book is -1.9612 because that is using secant method. This is using Newton method. And to get the exact root, you can use a solve button here. This solve button. Okay, this is a function. Okay, 0.5 plus this one. This is a function. I can shift solve. Okay, let's say I put negative 2, negative, okay, 1.9611. Yeah. Okay, this is using the solve button. Press a shift and then the count. You see the yellow color, the solve. Okay, this one you get negative 1.9611. If I put, let's say, negative 1. So far, we got 2 roots. Okay, another one. I put negative 1, I got another root. Okay, let me check this one, whether you have more than 1 root. Because a square, checking using another software. Okay, using the solve button. Okay, if you have more than 1 root, the root depend on the initial guess that you key in actually. Okay, I'm checking whether this equation you have 2 roots there, because you got the squared there, W squared. Mapper just give you 1, and we got another one, because okay, this should have 2 root because omega squared. Yeah, no wonder when you key in negative 1, you get another root. This one. Just now we key in negative 2. We get here. Okay, you can change. Let's say this one. You can recalculate again this one. Let's say if you change this one to change the initial condition, this is negative 1, so you will get the second roots there. Let me change it. Space on it. I just delete here. If I change this one to negative 1, okay, if you use Excel, okay, here you just change, okay, negative to negative 1, okay, the rest calculation will follow. But if you use calculator, once you want to change the initial condition, you have to recalculate everything again. Okay, luckily my formula is still here. Okay, so now, okay, I calculate here, add for negative 1. So I get negative 0.6615. Yeah. Okay, this is the F prime W function. Okay, this is correct. Calculate. Now x is -1. Okay, negative 0.0956. 57. Okay. So now okay, calculate again using the Newton formula. Here, calculate. A here is a okay. This is A, this is B, this is C. A is -1, B negative 0.6615, C negative 0.0957. So far. I calculate wrong. Negative 7 point so far 9122. Check whether I calculate correct. A -1, A -1, B negative 0.6615, C negative 0.0957. So 9122. Okay, negative 7.9122. I calculate wrongly. Let me check. This one, x -1. A -1, B negative 0.6615, C negative 0.0957. So means this is correct. Okay, and you proceed to calculate FW1. Okay, this one. Negative 7.9122, 0.4609. Okay. Calculate F prime W1. Okay, where the X is this. So you get negative 0.0121. So okay, you can see if you use calculator. Okay, once you change initial condition, because this one should have two root because you have the W squared, then you have to recalculate again. If you use Excel, then you just change here, this part only. Okay, so why this value jump so big? Okay, calculate. So now ABC, when you in row 2, ABC depend on row 1, which is negative 7.9122. Okay, B is 0.4609, C negative 0.0121. Something wrong. Let me check. Because from here jump to here, the value jumps so big. Okay, I'm checking any mistake in this one using Excel. Now f prime w 9.814 is so this is fw, f prime w. This one x, you may change it to w. Okay, I'm transforming to Excel because the second, okay, when I put, okay, the initial condition -1, the answer, I think, okay, run so big, so wet. So I'm going to check. This is f. Let's say now I put -1. Okay, fw.哎，你们拿我手机来一下。每次做就跑出去。Yeah. Muhammad Alif, I was out, okay? I didn't know because focus on solving. Okay, I'm hopefully it's recorded, Muhammad Alif, okay, what you want to ask? Muhammad Alif, okay, what you want to ask? I saw you raise up your hand. Okay, just now, okay, I don't know where since when I out, so I'm not sure. Now, okay, okay, which part? Then I out, Now, okay, okay, I'm checking using Excel because just now we obtained, okay, the solution when key in using -2, but using -1, but when using -1, okay, when using -1, the answer is from -1, I think run to 7 something, okay, okay, so now I'm checking using Excel, FW. Is 0.5 plus 9.81 divide 4 times. Okay, W is here, C17 multiply exponent exp w in C17 in my case plus sin w key to the wrong place here. Zero point 6615. Okay, 0.5. I'm checking. Okay, now using Excel here. 0.5 plus 9.81 divided 4 times w squared. Okay, negative. Okay, so now this is tally with the calculator. Negative 0.6615. Okay, and then key in the f prime w, which is 9.81 times. Okay, denominator 4 omega w squared have the bracket 4 times. This is w. Squared is this power symbol. Squared, close the bracket, multiply, open. Okay, exponent in Excel exp. Okay, w here, this cell exponent, open, close bracket, and then cos cos. Okay, click the cell of your w. Sometimes you cannot click, then you identify this is C17. You type C17. Any function in Excel, open, close, cos. Okay, close one more bracket because here you have open, close. Exponent, exp, open, close, cos, open, close a function. Okay, plus. Okay, lazy to type, copy. To C, cos change to sin. Sin sin 17. Multiply negative 9.81 divide 2 times w is C17 cube. Is there something wrong? the calculator is correct when these questions when the question 3 here, okay, the question asks to use secant, but your syllabus not covered, okay, secant, that's why, okay, I change it to Newton method, and then just now when we use -2, we can get the root, okay, the root, but we change to -1, the answer is, okay, very big, okay, we are checking using Excel is correct, okay, when -1, the answer tends to bigger and bigger, so means we cannot obtain the root. Let's say we put back -2, okay, that's using, so means if just now in calculator also we stop at here, here this one I didn't round, I just, okay, I just mean some sort like decrease the decimal place only, but actually it's just display purpose, but calculation it take up all decimal place. So similar with the calculator result just now. Okay, this is a function for FW. If we calculate x -2 just now, here, this one, this. This is a, okay, the F prime W. Okay, so you when you calculate W1, the A, B, C is actually W naught, F, W naught, F prime, W naught. Six. Okay, here negative 1.9606, and then you search back, okay, the function W, you calculate, I use back the answer. Okay, answer, then you tend to take out all decimal place. You get here this answer. Since, okay, just now I said, since the magnitude FW1 less than epsilon, which is 0.005, hence the approximate root is W1, which is negative 1.9606. But if you further do it until your FW can equal to 0, you said the root is negative 1.9611. Of course, this one is better. Okay, and just now, you said using this one, you shift solve this button. Let's say you put -2, you get this is a root. Okay, and then if you key in -1, you get this root, but okay, we fail to obtain this root using the Newton method here. As you see, put it -1, the answer is bigger and bigger. I fail to get it. -0.5. Then you get it. So means, okay, you put -1 just now, the answer bigger and bigger is seems like it's wrong. Okay, so I put negative, the initial, okay, guess which is close to the root, then we'll, okay, get to the roots there. Okay, so if you use calculator, once you change initial condition, the rest you have to change it again. But if you use Excel, you want to change initial condition, you just change, because FW is a, okay, is a formula where the FW 0.5 plus 9.81. So divide in Excel /. Okay, denominator here you have a 2 term. So make sure you open close bracket 4 times W. Click where is the location of the W. power, this is a symbol of power, power 2, close the bracket. This one multiply and then open bracket. Exponent is exp w, exponent and then open, click location of w, close your bracket for exponent and then plus, sin, open bracket, click where location of w, close the bracket, one more bracket. This is fw, f prime w that we obtained just now using the product rule. So key in accordingly. I can check my formula later. I will give you this one. So I will give you this template. So you can have a try to change the initial conditions there. Okay, thank you.